Hi students, welcome to Math4U. Today we are going to discuss about the property of rational numbers. So here we have the property, the distributive law of multiplication over addition in case of rational numbers. So I'm going to give you three rational numbers over here. As an example, let A by B, C by D and E by F are three rational numbers. Okay. So how can we say that this law is satisfying the condition given with these three rational numbers? So what is the condition? So here if A by B multiplied with C by D plus E by F, that is equal to A by B multiplied with C by D plus A by B multiplied with E by F. Okay, so this, if it is satisfying, that means if the LHS is equal to the RHS, we can say that this law is satisfying this condition. Okay, so let us see with an example. So I'm taking here three numbers, negative 3 by 4, another number 2 by 3, and the third number is negative 5 by 6. And let me check whether this is equal. So first step, we have to take the LHS. The LHS will be like negative 3 by 4 multiplied with 2 by 3 plus negative 5 by 6. So let us do the calculation. That is, first we are doing the bracket, right? Yeah. So negative 3 by 4 multiplied with, we are doing for the LCM here 3 and 6. The LCM is 6 and the numerator will come like 4 plus negative 5. Okay. So this will be equal to negative 3 by 4 and the numerator inside the bracket will be negative 1 by 6. So we can do the cancellation over here since it is multiplication. This will go 2 times, right? So this will be 1 by 8. So LHS we got it as 1 by 8. Now we are looking for the RHS. So what will be the RHS? Negative 3 by 4 multiplied with 2 by 3, right? Then plus negative 3 by 4 multiplied with negative 5 by 6. So how can we do this? Let us see. Here in the first bracket itself, we can cancel these two, right? And this 3 one time. So we will get as negative 1 by 2 plus. What about the second bracket? You can cancel here 2 times, right? So this will come like negative 5 by 8. So now we are going to check with the LCM of 2 and 8, that is 8, you know, and the numerator will come as negative 4 plus 5. So what will be the answer? 1 by 8. So here you can see the LHS and RHS are equal. So what can we say? We can say this condition, that is A by B multiplied with C by D plus E by F will be equal to A by B multiplied with C by D and plus A by B multiplied with E by F. So this is called the distributive law of multiplication over addition. So let us see another properties of this rational numbers. The existence of additive identity. What is the existence of additive identity? Okay, so let us see. 0 is a rational number. If we are taking the 0 as a rational number, okay, such that the sum of any rational number and 0 is a rational number itself. So I will give you an example for this. Let us see an example. That means with, if A by B is a rational number, okay, we have taken with A by B. So according to this, A by B plus 0 will be equal to 0 plus A by B, and you will get the rational number A by B itself. Okay, let us see an example. Negative 2 by 3. Okay, negative 2 by 3, you know that is a rational number. I'm adding 0 to negative 2 by 3. Okay, is there any change if I am adding like this? No. So that will be equal to negative 2 by 3. You can see another one more example on this. Okay, so 3 by 5. Let me take 3 by 5. Okay, 3 by 5 plus 0 will be equal to 0 plus 3 by 5, and that is equal to the number, the rational number 3 by 5 itself. Is that clear? Yes. So let us move ahead with existence of additive inverse. So what is called additive inverse? First of all, we have to learn that, right? So here I have taken a number a by b, right? In this, you can see for every rational number a by b, there exists a rational number negative a by b, such that when we add this rational number with the negative a by b, you will get 0. So let us see how it is applicable. So here, according to this, a by b plus minus a by b will be equal to, how it will be? The denominator will be b because LCM, and you can take the numerator a plus negative a. So what it will be? The numerator is having opposite sign. You can say that is 0 by b, that is equal to 0. Very good. So here we can say this negative a by b is the additive inverse. This is the additive inverse of what? Yes, very good, a by b. So let us see with an example. I'm taking here 4 by 7 as a rational number, and I'm adding the additive inverse. What is the additive inverse of 4 by 7? I told a by b. For a by b, the additive inverse of is negative a by b. And for 4 by 7, what will be it? Yes, negative 4 by 7. You have to change the sign. That is what you have to do. Okay. If it is negative, what it will be? I'm giving you an example here. Negative 5 by 3. What will be the additive inverse? Yes, 5 by 3. So you have to change the sign. That is what you have to do. So what will be the answer for the example what we have taken? 7 is the denominator and 4 plus negative 4, that will be 0 by 7. The answer you will get as 0. So is that clear? Yes. So let us move ahead with the next property. How can we subtract a rational number? So let us see what is the peculiarity what we have to do here. So let us take two rational numbers as a by b and c by d. Okay, I'm going to subtract these two. Let us see what is happening. A by b minus c by d. Okay, so this is subtraction. So what we have to do here is, in the next step, what do we have to do? We have to take the additive inverse of the second number, that is a by b, and the additive inverse of the second number is what? Second number is actually positive, right? The negative here given is the operation. So what is the additive inverse of c by d? The positive number will change to negative, right? Negative c by d, and you have to add it with the first number, first rational number. So this is how you have to do the subtraction. That means this is equal to a by b plus additive inverse of which number? Yes, c by d. That is negative c by d. You got it here. Okay. So let us see with an example. So I'm going to give an example like 1 by 2 minus negative 3 by 2. Here it is subtraction and the second number is negative. How you will do? Yes, 1 by 2 plus you have to take the additive inverse, that is 3 by 2. So I took the additive inverse of the second number, that is 3 by 2 positive, and you have to add with the first number. First number I mean is a rational number. Okay. So here, how can you do? That is, the denominator is 2, the numerator is 4. That is 4 by 2, and you can get the answer as 2. Clear? Yes. So let us see the next. Existence of multiplicative identity. You have seen the existence of additive identity, right? Yeah. Similarly, we are going to check out the existence of multiplicative identity. So here I am going to take a rational number a by b such that when we multiply it with 1, or we are doing it in the reverse order also, we will get the rational number itself. So this is called the existence of multiplicative identity. So which is the number here, the multiplicative identity? Yes, 1 is called the multiplicative identity for rational numbers. The number 1 is the multiplicative identity of rational numbers. Yes. So let us consider a rational number 3 by 4. Okay, 3 by 4 is a rational number, you know. Then how can we do it? So 3 by 4 multiplied with 1 is equal to, we can say that 1 into 3 by 4 also same. How can we do this? 1 means 1 by 1, right? Yes, that is equal to 3. 1 into 3 is 3. 4 into 1 or 1 into 4 is 4. So the answer is 3 by 4, right? Yes. So this is called the multiplicative identity. So let us see what is the existence of multiplicative inverse. So here every non-zero rational number a by b has its multiplicative inverse as b by a. So the reciprocal is the multiplicative inverse. That means when it comes to additive inverse, it will be the change of the sign, and when it comes to the multiplicative inverse, we have to take the reciprocal. So here multiplicative inverse means a by b will be changing to b by a. Clear? So let us see here which will be the reciprocal. Here this is the change happened, and you can see that 0 is having no reciprocal, right? Yes, let me ask you one question. What will be the reciprocal of 1? Reciprocal of 1? Yes, that is 1 itself, right? And what will be the reciprocal of -1? Same, -1 itself. Very good. So let us see an example for this. So I'm taking an example as -8 by 9. What will be the reciprocal of -8 by 9? The reciprocal of -8 by 9 will be -9 by 8, right? And let us see another one more example. What will be the reciprocal of -3? What will be the reciprocal of -3? Yes, -3 means that is -3 by 1, right? So the reciprocal is -1 by 3. Okay, so this is the reciprocal of -3, and this is the reciprocal of -8 by 9 here. Okay, so let us see the next. That is multiplicative property of 0. So every rational number multiplied with 0 gives a rational number. That means if I'm taking a by b as a rational number, let a by b a rational number. So we can say that a by b multiplied with 0 or 0 multiplied with a by b, it will be 0 itself. Okay, this is same like what the numbers are. When a number multiply with 0, you will get 0, right? So let us see an example for this. I'm taking a rational number, -12 by 17, okay, and I'm going to multiply it with 0. So let us see what is the answer. You can do -12 by 17, 0 means 0 by 1. So what will be the denominator? Denominator will be like 17, and the numerator will come as -12 multiplied with 0. That is again 0 by 17. You know, 0 divided by any number, the answer will be 0, right? Similarly, if you are doing 0 multiplied with -12 by 17, also you will get the same process, that is 0 itself. Okay, so these are the properties of rational numbers. So with this session, we have finished the properties of rational numbers, and next session we have seen how to find out the rational number between two rational numbers. Okay, thank you.